Okay, let's get started with the notes for 4.7. This section is again about factoring, and really this section, the goal for you should be all about recognition. The idea when we're factoring binomials, particularly the special cases that we're about to look at, is if you can see them when they go by, it will make your life a ton easier. If you can look at something and go, oh, I know what that is, then you know what to do with it. So we're going to talk about difference of squares, difference of cubes and sums of cubes, and just a general factoring of binomials with higher exponents. So a difference of squares is when I have one square, like I have a squared here, something squared minus b squared, okay? When I factor that, it's the base value of the first square plus the base value of the second times the base value of the first square minus the base value of the second. That's how it works every time. What you don't see on here is anything about a factored form for a sum of squares. If instead of a minus here, oops, I need the pen to work. Sorry, let me get the right pen. If instead of a minus here, I had a squared plus b squared, that's not factorable the same way. Most of the time, that's not factorable at all. A difference of squares is, but if there's a plus sign here, it's a different situation, so you have to be really careful. Okay, so let's look at what we have. This is a difference of squares. I can see it. It's an x squared, that's a square. 16 is a perfect square, and 9 is a perfect square. Here's the other thing. If you don't know the perfect squares and the perfect cubes off the top of your head, go make yourself a list on whatever notebook you're keeping. Put it in the back of your notebook or the front of your notebook or on a sheet of paper on your desk somewhere. It is very handy for you to be able to know those. Probably through 100 for the perfect squares, for the perfect cubes through like 7 cubed, I would say, or 8. Just to be able to go like, oh, I recognize that number. So like when we're talking about a list, I'm talking about 1, 4, 9, 16, 25. Perfect squares, right? 36, 49. Perfect cubes are going to be 2, 1. 2 cubed is 8, 3 cubed is 27, and so on. 4 cubed is 1680. Well, my brain just broke. Sorry. I don't always know them off the top of my head when I'm trying to talk, which is my problem. It's 64, which is what I was going to say. Good Lord. 64, okay? And then you keep going on, 125. You should make yourself a list somewhere if you don't have these right in your brain. Right now we're dealing with squares though. So the base number that 16 is the perfect square of is a 4. The base number that 9 is a perfect square of is a 3, right? So I'm going to make my 2 binomials. I know it has to be plus and minus. It's going to be 4x and 3 and 4x and 3. And that's my difference of squares. There it is right there. I didn't have to use the AC test. I didn't have to think about products. I didn't have to do any of that. This is my binomial. It's perfect square. I'm moving on. All right, do the same thing here. So think about what the squares are and what the bases are and what goes in each place. So the base here is a 2. The base here is a 1. This is definitely a minus sign, so I can get this to work. So I'm going to have 2z minus 1 and 2z plus 1. It doesn't matter if you do plus or minus first. It just matters that they're both there, right? Okay, let's look at another one. This one is funky looking. It certainly doesn't look like a difference of squares. It's a difference, but I don't see a square here. But I do see common terms, okay? So sometimes perfect squares are buried underneath things. So let's see, if there are common terms here, what are they? I see, they're both even, so it's gotta be a 2, right? And then they both have a d. So I'm gonna take out 2d. Let's see what I get. I get 49, 98 divided by 2 is 49. C squared, the d goes, minus 50 divided by 2 is 25. D squared. And look at that. Now 49 is a perfect square, so is c squared, so is 25, so is d squared. I have a difference of squares again. So I'm going to change color. That gives me 2d. I'm going to make my two binomials, minus, plus. The base here is a 7 and a c. This is a 5 and a d. This is just a hitchhiker, this d. It's just there, okay? So I'm going to do 7c minus 5d and 7c plus 5d. That's all it is, okay? So the thing is sometimes you get down to a binomial and you go like, oh gosh, what do I do with that? You should think like, is anything here a perfect square? Because that would make this a lot easier. And a lot of times that is. All right, let's try this one. Let's see, there's got to be common terms in here, right? I see everything's divisible by 7. Everybody's got a y and everybody's got a z. So let's do that. So let's pull out a 7yz. What's left? Y squared minus 9z squared. And again, 7yz came out. Y squared is a perfect square, 9 is a perfect square, and so is z squared. So now I have, because there's a difference in there, a subtraction, I have a difference of squares. The base here is just y. The base here is 3z, so that's what I'm going to use. So I have y minus 3z, y plus 3z. Remember, at any point that you need to, you can stop these and rewatch. You can pause and think for a minute. All right, so this one has a 4 instead of a 2 as the exponent. Scary. Here's the thing. Don't let that freak you out. It's just an exponent, okay? Think about what it really means. So z to the 4th is really just z, 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 z. If I was going to take that z to the 4th apart, any even exponent here can be taken apart into 2 groups. That's the nature of being even. So I can divide it into 2 sets. That's all I need to do. Really, it's just made up of z squared and z squared. So this is a perfect square, that 4. So I'm going to take this apart. The base here is z squared. Well, those look like 2 2's. And the base here, the 81 is a perfect square too. That's a 9. So I'm going to make my 2 binomials. So I have z squared minus 9, z squared plus 9. Now you have to stop and think for a minute. Are we finished? Well, no, right? Because z squared minus 9 is another difference of squares. Those are both perfect squares. Z squared plus 9, remember, I can't factor across a plus sign for perfect squares. That's not going to work. So here again, we're going to look at it the same way. The base here is a z, the base here is a 3. So I'm going to do z plus 3, z minus 3, and then I get to keep the z squared plus 9 just as it is. Okay? Okay. All right. This one works exactly the same way. You can try that on your own. We're going to move on. Oh, shoot. So if a and b have no common factors, the sum of squared, these should be exponents. I don't know why this keeps retranslating. I keep fixing them, and they keep giving themselves back. A squared and b squared. We cannot factor it. We said this before. So a squared plus b squared is prime. When you see this, the answer is this. Okay? Okay. All right, so now let's factor by grouping. It says using a difference, of squares in a group, in a grouping. So let's stop for a second and look at the process the way we always do. Do you see any common terms? I don't, so I don't see anything else to take out. So I'm going to leave that be. So now let's just make groups. I know how to do this. Here's my 2 groups. Let's see what happens. Well, in the first group, I can take out y squared. All right. I'm left with y minus 6. In the second group, I can take out negative 4, right? So I'm going to take out negative 4. I'm going to get y minus 6. All right. My common binomial is y minus 6. I'm going to pull that to the front. and then collect the rest, I get y squared minus 4. This is where you have to stop and look, right? We're talking about difference of squares. Here, right in front of us, is a difference of squares. That's why the recognition of it is really important. Because if you're not recognizing it, you're going to stop here, and your problem's not complete. So I'm going to take this apart. The base is a y, the base is a 2. So I'm going to keep y minus 6. I can't ditch that guy. He's part of it. My first binomial is y minus 2. My second is y plus 2. All right? Okay. Same process here. You try this one. I will tell you when it works out, you should get a minus 3, a plus 3, a minus 5. Okay. Oh, sorry, a plus 5. You try it, see if you can get that same answer. Okay. All right. We're going to try, this one is factoring a 4-term polynomial by grouping 3 terms. Sometimes it works better to just take a second and go like, okay, wait, this one grouping 2 things together doesn't really help me, right? I can do this particular problem a couple of different ways. But the way that Alex is going to want to do this is a little different. So the way I'm going to think about this one is I know I can make all of this go together. All right? I am going to move this around a little bit. Y squared minus 6y minus 9 plus x squared. The x squared is like the odd man out here, right? So I'm just going to ignore him for a second. I'm going to factor a negative out of this first set, these 3 terms. I'm just going to pretend x squared isn't there. So I'm going to pull out this negative, okay? I'm going to take out negative 1. That's going to make this y squared plus 6y plus 9 plus x squared. The parentheses have to go at the back of the 9 because that negative 1 has to redistribute there. Now I'm just going to factor what's inside here. Well, I could use AC test. I can use my sort of logical thinking. I know it has to multiply to 9 and add to 6. So that's got to be 3 and 3. I know both signs have to be pluses because everything's positive. Y plus 3, y plus 3. All that has to get applied to negative 1 plus x squared. And that's how that works. You can leave that like that, okay? Or we can redistribute things. All right, whatever works for you. This works the same way. I would gather up this, factor it, and then just leave this guy alone. That's fine, okay? So this is going to be x squared plus 10x plus 25. Let's see, 5 times 5 is 25. 5 plus 5 is 10. So it'd be x plus 5, x plus 5. Minus y squared. It's okay, sometimes everybody doesn't fit. Things happen. All right, the other part in here that we have to handle is the sum and difference of cubes. This is different from squares because I can factor both sums of cubes and differences. So what changes is just a little bit of the structure of this formula. So when this is something, to be quite honest, there is no really easy way to do other than memorize. There are very few things that are going to come that way in this course. This is one of them, okay? You have to remember this structure. Here's the way I think about it. In the formula for a sum or difference of cubes, this is the base, A, okay, whatever. So if let's call this, let's say it was a 27. 27 is the same as 3 cubed. Oop, that's got to be a cube. Oh, that's an ugly number. Okay. The base of 27 is a 3. So I'd put a 3 there. The same thing, let's say this is an 8. 8 is 2 cubed. The base of that is a 2. I'd put a 2 here. Okay. Then I look at the next parenthesis set, the trinomial here. I think about the base number. Okay, for A it's a 3 and I square it. 3 squared is 9. so I'd put a 9 there, minus a times b, 2 times 3, which is 6, okay, plus b squared. In this case, b squared, it'd be 2 times 2 is 4, all right? The only difference between these two things here is where the minus sign is. In both setups, there are 2 pluses and 1 minus sign. In a sum, the plus sign comes first. In a difference, the minus sign comes first. That's all it is. It's always plus b squared. Okay, so all you really have to remember once you grab onto this formula is where the minus sign goes, depending on if it's a sum or a difference. All right, so let's actually try one of these. So I have 8x cubed minus 27x. What that means is when I set this up, the minus goes in the first set. Plus, plus, okay? So now I have to think about the bases. 8 is 2 cubed, so the base is a 2 here. X cubed, the base is just x. 27 is 3 cubed, so it's a 3. All right, so in this first parentheses, I get 2x minus 3. It was just a minus b. In this spot here, the first space in the second parentheses goes a squared. So 2x times 2x would get me 4x squared. And the next spot, it's a times b. 2x times 3 would be 6x. And then the last spot, it's b squared. So 3 times 3 is 9. It's finished. That's it. All right. Let's try another one. This is also a difference. So the setup is the same. Minus, plus, plus. Look at the bases. 125 is 5 cubed, so the base is 5. P cubed is p. 8 is 2. And so let's put things into place. It's just 5p minus 2. And then in this first spot, it's 5p squared, which would be 25p squared. A times b is 5p times 2 is 10p. And then 2 squared is just 4. Finished. If it is a sum, this example is a sum, right? All that changes in that process is where that minus sign goes. So set up what you have. This plus sign comes first, then a minus, then a plus. And now we're going to treat it exactly the same way. So the base of 125 is 5. The base of t cubed is t. The base of 64 is 4. The base of z to the 6th, well, let's think about that. If I have 6 z's, and it's a cube, I want to make 3 groups. So each one has 2 z's, so it's bz squared, which is like the most difficult thing to write in these markers. All right, so then we put our stuff into place. 5t plus 4z squared. Now it's a squared in that first spot, so 5t times 5t is 25t squared. A times b in the second spot, 5t times 4z squared would be 20t z squared. And then b squared is in the last spot, so 4z squared times 4z squared gets me 16z to the 4th. Finished. Okay. Let's try this one. Same thing. It's a sum, so plus sign goes first. That was a terrible parenthesis. Pardon me. Plus, minus, plus. All right. The base here is just x. 1,000 is the cube of 10. Y to the 6th we just saw is the same as the cube of y squared. Put things into place. X, 10y squared. X squared is just x squared. X times 10y squared is just 10xy squared. And then 10y squared squared would be 100 y to the 4th. Finished. That 4 should be in the parentheses, but it didn't fit. All right. So here's the summary. Here are the things you can do now. You can find a difference of squares. You can find a difference of cubes. You can find a sum of cubes. It is super important that you recognize when these things show up, because you can see there's not like a super simple way to just dig your way through to them. Knowing the formula is half the battle. The other half is recognizing that one of them happened, okay? All right, so now let's factor something a little more complicated. It's not so scary, it's okay. But let's think about what's happening here. Well, m cubed, let's think about what this is. Is it a difference of squares? No. What is it? It's a difference of cubes, right? M cubed is a cube. This 8 down here is a cube. Even though it's in the denominator, it's okay. So this is a difference of cubes. The base here for the first term is m. The base for the second term is half. I know, it hurts you to write a fraction. Don't be hurt by fractions. Fractions are friends. So set up like you would for a difference of cubes. Minus, plus, plus. Put things into place. So this would be m minus half. M squared here. And times half is just half m. Half squared, so half times half is 1/4. Finished. It was not as bad as it seemed. What is this one? Well, nothing is cubed, right? No common terms. Nothing is square. What do you think this is? Can you do anything else to it? Oh, there is a common term. Do you see it? It's a 3. So pull out a 3. So I got 3k squared left plus 8m squared. Honestly, nothing to do after that. Okay, done. But there was a common term. Let's look at this one. Looking at it, what do you think it's going to be? We'll have to see. I see a common term to start with. Let's pull out a 2 and see what happens. So 128 divided by 2, well, 100 divided by 2 is 50. 28 divided by 2 is 14, so that gets me 64. Plus 54 divided by 2 is 25, 26, 27. Okay. Well, now what do you see? I see a sum of cubes. So let's set that up right. Okay, keep the 2. And a sum of cubes, the plus goes first. Now let's think about the bases. The base cube of 64 is 4. I'll write that in a different color. For y to the 6th, it's y squared. For 27, it's 3. And for x cubed, it's x. So let's see. In this first spot goes 4y squared. The second spot goes 3x. 4 squared, that whole thing squared, would be 16x to the, or sorry, y to the 4th. 4y squared times 3x would get me 12. I didn't give myself very much room. Y squared x. And 3x, that whole thing squared, gets me 9x squared. All right, it wasn't so terrible. What's this one? Think about it for a second. Well, let's see. Let's pull out a common term first, right? Okay. 2, it gets me 25 y squared minus 4x. Oops, sorry, that's a 6. Y to the 6th. 4x squared. What do you see? I see a difference of squares. Okay. So that 2 stays. 25 is the square of 5. Y to the 6th is the square of y cubed. Minus 4 is the square of 2. X squared is the square of x. And now I just need to repeat that with a plus sign. Finito. All right, we're just going to look at these. You should be able to go through them and try each of them. If you have questions about it, drop it in the chat. Let's see how you do, okay? Factor the binomial as a difference of cubes, okay? So let's see if we treat this as a difference of cubes, what it looks like. Well, if this is a difference of cubes, what's the base? Think about that x, 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 3x, 6 x's. Derive it into 3 groups. So the bases would be x squared and y squared. This is a difference, so the minus comes first. So we'd get x squared minus y squared, and then we'd get x to the fourth, x squared, y squared, oops, and y to the fourth. Okay, it's done. Do you notice anything here? I noticed this is a perfect square, right? So I can further break that down into x minus y, x plus y. All right. We can also factor this as a difference of squares, can't we? Because let's think about those x's again. I can divide it into two groups just as easily. So the base would be x to the third and y to the third. So it would be x to the third minus y to the third, and x to the third plus y to the third. All right, this is the end of the notes for 4.8. From here, you have assignments to do in this unit. Start with your ALEKS work and get into the chat, or sorry, into the discussion thread. Let's see some questions, help each other, and we'll go from there.